Hello, Year 8. Today we're going to learn about scale drawing and finding measurements using a ratio scale. So anytime that you have a map or some building plans or those kinds of things, on that map or building plan there needs to be a scale that tells you how to read it. So a ratio scale of 1 to 100 means that the actual length is 100 times bigger than the one that you've measured on the diagram. The first number represents what is on the map or the scale drawing, and then the second number represents what it is in real life. So 1 centimetre on the map would be 100 centimetres or 100 times bigger in real life. Scale drawing is things that have the exact same shape as the original object but a different size. So we've either made it much, much bigger or much, much smaller, usually when we put things on maps, so that we can see it all in one spot. So here is an example of what a scale drawing could look like. So this is looks like a little extension maybe that somebody's doing on their house. They have a little garage and a storeroom there with a water closet, which means a bathroom. So you can see measurements all around there, but the important thing down the bottom here is our ratio scale. So you'll notice that there's no centimetres or millimetres written on that plan, but whatever the units are, the real measurements are 100 times bigger. I want to draw a little diagram for you to help you with this next section of work. Some questions we're going to be working out what we call the actual distance, and other questions we need to work out the scale distance. Okay, so to go from actual distance to the scale distance, you need to divide by the scale factor. And from scale distance to actual distance, that's getting bigger, so you're going to times by your scale factor. The scale factor is the second number in your ratio. So the ratios that you'll be given will be 1 to some number. So this question here says 10,000, 1 to 10,000. So that 10,000 is your scale factor because it is the real measurement is 10,000 times bigger than the map measurement. All right, so to do the question 1, a map has a scale of 1 to 10,000. Find the actual distance for each scale distance that has been given to you. Convert the actual distance into an appropriate unit. Well, we'll talk about that bit when we get to it. So because the 2 centimetres that I've been given here is a scale distance, so it's what you've got on your house plan, if you like. So if I measure 2 centimetres on my house plan, so this is a scale distance, I'm going to times by my scale factor, which is 10,000 for this question. 2 times 10,000 is 20,000. 20,000 what? Well, because the two that I was given in the question was in centimetres, that means this number is going to be in centimetres. 20,000 centimetres would be a lot of centimetres to try to measure out. It's not a very appropriate unit. So what we want to do is convert that into one of our bigger units so it makes more sense. So you probably remember charts like this. If I want to go from millimetres to centimetres to metres to kilometres, as we go into bigger units, we need to divide. So dividing by 10, divide by 100, divide by 1,000. Going from bigger to smaller units, you want to times. So times by 1,000, by 100, by 10. Okay, so if I have 20,000 centimetres, which are here, I could divide by 100 to turn that into metres. So on the side, let's go divide by 100. 20,000 divided by 100, you could do it on your calculator, but it takes 2 zeros off, so that makes 200 meters. Now 200 meters makes a lot more sense, so something that I can visualize, than 20,000 centimeters. So it's a much more appropriate unit. Let's do another one, part B. 5 millimeters is the map or the scale distance, which means I have to multiply it by my scale factor, which is 10,000. 5 times 10,000 is going to be 50,000, and this time this is going to be in millimeters because my question was in millimeters. 50,000 millimeters would be ridiculous to try and measure. So to go from millimeters, let's go to centimeters first. I would divide by 10, which would be 5,000 centimeters. That's still a lot of centimeters. Let's change it again. So let's go down another one. Let's divide by 100, which would take off 2 more zeros, and that would be 50 meters. So you keep dividing down, but don't go into anything less than 1. So you don't want a 0 point something answer. As long as you're still in numbers above 1, then we divide down into bigger units. Okay, let's do one more of these. We have 14.3 centimeters. So we're going to times that by our scale factor, which is 10,000. And that will make 143,000 centimeters. Far too many centimeters, so we're going to follow our arrow across here, and we're going to divide by 100 to turn it into meters. So that takes off 2 zeros, so 1430 meters. If I wanted to change that again, which I should because that's still a big number, to change that into kilometers, we would now divide by 1,000, giving a final answer of 1.43 kilometers. So it's still above 1, but 1.43 kilometers. Next question, question 2. A model car has a scale drawing of 1 to 200. Find the scaled length of these actual lengths. So these are the real measurements. The car's real measurement, maybe its length, is 3 meters long. What is that going to be on the map? So remember my diagram back here. If I have the actual distance, I need to divide by the scale factor to find the scale distance. My scale factor this time is 200. So I start with 3 and I divide by 200. This is going to make a very small answer. 3 divided by 200 is 0.015. Now the reason that's so small is because it's in meters, because the number in the question was in meters. We wouldn't really measure things on a model of a car to be in meters. We need to turn that into a better unit. So using my conversion chart here, to go from meters to centimeters, I'm going to times by 100. That makes 1.5 centimeters. So a 3-meter car in real life is going to be 1.5 centimeters on the drawing of it. Makes sense, doesn't it? It's always good to check that your answer is actually logical. Part B, let's do it again. 500 centimeters in real life. We're going to divide it by our scale factor because it's shrinking down. And 200 divided by 500 divided by 200 is 2.5, and the units will be in centimeters. And that's already a perfectly acceptable unit, 2.5 centimeters. Done. Question 3. Determine the scale factor for the following situations. 5 millimeters on a scale drawing represents an actual distance of 50 centimeters. So I'm trying to turn this into a scale factor, which we know is written as a ratio. So the scale drawing number goes first, 5 millimeters will go first, And then the real life measurement, which is 50 centimeters, will go second. But if we have different units in our ratio, we need to make them the same so that we can simplify it down. Centimeters is the bigger unit, so I'm going to turn the centimeters into millimeters by timesing by 10. That means that I have 5 millimeters to 500 millimeters, and because they're both in millimeters, I don't have to write the mm for millimeters anymore because the units are the same. Now I want to simplify the ratio, and both of those numbers can be divided by 5. 5 divided by 5 is 1, and 500 divided by 5 is 100. So my scale factor is 1 to 100. Question B. Doing the same kind of question again, we have an actual length of 0.2 millimeters is represented by 10 centimeters on the scale drawing. So the scale drawing needs to go first. So the scale drawing is 10 centimeters, and it represents an actual distance of 0.2 millimeters. So this is an example of when we're actually making something bigger. The real measurement is something very, very tiny. Maybe we're measuring an ant here. That's 0.2 of a millimeter. Maybe it's even smaller than an ant. And then we're making a drawing of it much, much bigger. It's 10 centimeters for the drawing that we're going to do of it. So to fix this up, we need to make our units the same. 10 centimeters, we can convert that to millimeters by timesing by 10, so that we would have 100 millimeters and 0.2 millimeters. I don't actually need the millimeters anymore because they are now the same unit. I can just go 100 to 0.2. To simplify those, it's a bit tricky to know what we can divide by. So remember that you can also do these in your calculator. You could go 100 over 0.2, and it will simplify it down to 500 for you, which means it's going to be a 500 to 1 ratio. So the drawing is 500 times bigger than the real thing is what that means, because the bigger number is first. Okay, that's the end of our theory section. You need to do pages 8 to 10, please.